22, 22? Probably not, right? Okay, so what we do is we get the difference. We take each of these and we boil it down to a single column. And we have this difference. So 3 subtract 6. So you're just going to take, you're going to take A and subtract B. And so instead of having this data and this data, you're going to boil it down to just a single one sample would be one sample test, which you already know how to do from econ. And then what we do is we don't call it X bar anymore, we call it D bar. D bar is the average difference. So what we do is we just look at all those little differences. I'll move it over here so we have it. We look at all those differences and we add them up and divide by 5, because our n in this case is 5. And we go -3, +1, +2, subtract 3, subtract 2, divide by 5. And we get a value -1. And we also get the standard deviation for the difference. And that will be S subscript D, which you already know too, from your econometrics toolkit. And you just take the square of those. This would be D squared, D divide by n minus 1. And I'm going to save us some time and calculate it for us. It ends up being 2.35. You remember this? This little formula, it's the sample standard deviation, little s. I'm putting a little d there because it's on the difference. And I get 2.35. And now we have everything we need. We can just go ahead and run the test. There's the point estimate. What we just did, add up all the D's, divide by n, which was 5 participants. And there's our fancy, I guess they're calling it D. I guess I could call it D here, because it's the difference values. And yeah, it's basically the same. It's identical to the same what we just did. And then you can get your confidence interval. Now, again, this is if the two populations are related somehow. Right. So I do this, if you want to know an example, I'll do this example. I will look at midterm grades to see if I can predict the final grades. That is related because it's the same students, it's the same class. So it would be a related, because it's the same students at the midterm and the same students at the final. And I can pretty much predict. It's actually pretty good. But if I want to compare last year's class averages to this year's class averages, then I don't use this. I use what we started the lecture off with, the 2 independent samples. Because they're independent. Last year's students are not related to any of you, right? So that would be 2 independent. So you can see how you have to think about it for a moment. Are they related or are they not related? Right? And here are the brands of chips. We've already done it. Develop the 95% confidence interval. And so it's just going to be this D plus or minus RT. And it's going to be a 0.025 on 4 degrees of freedom because n equaled 5. Right? There were 5. And then we're going to have our S subscript D. And we already have all this. So it's going to be -1 plus or minus. We need to get that T. So we'll go over to the T table again. 4 degrees of freedom. And I'm going to pick 2.776. Everybody okay with that value? 4 degrees of freedom for a 95% confidence interval would be 2.776. 2.776. And I'm going to multiply that by the sample standard deviation of the difference. And that ends up being you can do this with me. -1 plus or minus 2.92. And I end up getting that -3.92 to 1.92. Aha. Uh-oh. 0 is in there. So how do we conclude? That means that, is there a difference between the chips, the brand A chips and the brand B chips? Remember, we got to take it, we always have to circle back to the data. Right, you're shaking your heads and that's correct. It's no, right? Because 0 is in the interval. So we conclude this, since 0 is within the interval, we conclude there is no difference between the brands of chips. So this is used all the time for taste tests, right? Coke and Pepsi, can you tell the difference? Yogurt and ice cream, can you tell the difference? So anything that's comparing, and it's the same participants giving a rating for each to see if they can tell the difference, then it is that. Or if it's midterms and final of the same students, it's basically, if it's the same people, then it's the related methods that we just did. You boil it down to a single confidence interval. If it's two completely different groups of students or two completely different groups of employees or whatever, completely not related, then you use the two sample independent samples, right? Two sample methods. All right. Chips. There we go. And there's again, this can expand to the test statistic. You can do it as a hypothesis test with comparing production methods. You could also take these data and run a confidence interval. That's what I usually do. I usually use confidence intervals for all these because the confidence interval gives me those magnitudes from a minimum to a maximum, which is very, very useful. These are good if you just want to get, you know, how large of an effect it is by seeing the p-value and so forth. So we can get the difference. So the difference is 1 subtract 2. And we do that by getting 6. And then negative, it's going to be 0.6. And then negative 0.2, 0.5, 0.3, 0, and 0.6. And you just use that difference column. Again, when you tell the software what you want, is it 2 independent samples or is it 2 dependent samples? Then it will just do all this internally for you. But since we're doing it by hand, so we can really see and understand what is happening here. So D bar will be what do you guys get? I have a note on my lecture notes to verify this because it may have been done too quickly. And what do we divide by? N in our case is, right? And notice it's related because we have the same workers with different completion times, like the same workers. So they're related if you have the same people with 2 different samples. So divide by 6. Yeah. Is 0.3, 0.3. And to save time, I'm going to give us this standard deviation is 0.33. Might want to carry more decimals, but that's what we got. So we just go step 1. the H naught is the difference is equal to 0, capital D, because it's the population, versus the difference between the times is not equal to 0. So we're comparing the completion times between 6 workers to see if there's a difference in 2 different production methods. So you use the same workers and then you run this related test. Step 2, what's the test statistic? It's going to be a T with D divided by S subscript D divided by the square root N. When we did this, did we divide? We divided by the square root. And oh, this should, I'm just going to grab a correction here. This needed to be divided by the square root N, which was divided by the square root. The numbers are correct, but I didn't put in the actual square root because we need it to be right here. Square root. So add that to your slide 30. Those square roots, I'll just put it in a different color. I'll highlight right here and here. The numbers are all correct. I just didn't write those down. Sorry about that. So we're going to add those in for the chips and get back down to here where we have the square root. And that ends up being, and again, you guys, everyone can check and verify these to see if, and convince yourselves that it's correct. And if there's any discrepancies, absolutely let me know. Right, and we'll use 5% again. And step 3 is going to be the T star, the critical value. And we're going to find it at that on 5 degrees of freedom because there's 6 workers. So let's get that value from the table. Let me just grab that value. It's going to be 5 degrees of freedom. It's a 2-sided test, so we're going to divide alpha by 2, right? So it's going to be this column here. 5 degrees of freedom, because there were 6 workers. We're going to use this value right here, 2.571. 2.571. By the way, all these tables are on Brightspace, and I highly recommend you print them out because they're easier to use without having to look on a screen. You can just have the table right there. It's basically the output of, I made these tables. This table here was made in R, right? So they're really accurate. We've done with R. It's going to come back. So we're going to look at step 4. So we're going to compare these. So we compare and we go, is this greater than this? So since step 4, since the observed T, is it greater than the critical value T? No. In this case, it's a no. So the observed T is not greater, right? Because it's 2.23, and the critical value T from the table, remember critical table T, is 2.571. So since it's not, we then, what's our conclusion? Can we reject or not reject? To reject, or do we not reject? We cannot reject. We cannot reject the null hypothesis. We can only reject it when our observed T is greater, just like we've been doing. So if it's not greater, then we cannot reject. And the test then is not statistically significant at the 5% level. And we then conclude that there's no difference in the production speeds. Right, always go back to the context of the original data, there's no difference between the two production methods.